half-angle formulas. We have talked about sum and difference formulas. We've talked about double angle formulas. Now we're going to talk about half-angle formulas. The basic idea here. We're going to look at the formula for cosine 2 theta. We could say that it is 2 cosine squared theta minus 1. That was our formula for a double angle. But if we let theta be like alpha over 2. Why are we doing that? Because we want to develop a half-angle formula. Then what we get is cosine of 2 times alpha over 2 is 2 cosine squared alpha over 2 minus 1. And that's helpful because we get 2 times alpha over 2 is just alpha. So cosine alpha is 2 cosine squared alpha over 2 minus 1. And at this point, we want to get cosine alpha over 2 by itself, and that will be our half-angle formula for cosine alpha over 2. First step is to add 1 to each side. Like this. What would our next step be? When we divide each side by 2, we get cosine alpha plus 1 all over 2 is cosine squared alpha over 2. Which leaves us with only one more thing to do, which is what? So the last step tells us that plus or minus the square root of, and we are actually going to write it as 1 plus cosine alpha over 2. That is cosine of alpha over 2. So this is our formula, half-angle formula for cosine. So on this page, we can write it now. We say this is plus or minus the square root of 1 plus cosine theta all over 2. We had alpha on the last page, but now we're using theta. It's a variable, so it doesn't matter if you change it. To get sine theta over 2, what we're going to do is we would go with that same deal where you let theta be alpha over 2, but you use this formula for cosine 2 theta. And if you solve that same way we solved the other one, you're going to get that sine theta over 2 is plus or minus the square root of 1 minus cosine theta all over 2. So the half-angle formulas are exactly the same, except sine is 1 minus cosine theta here, cosine is 1 plus cosine theta. In a problem like this, our life is easier because the formulas we had on the last page, sine theta over 2 or cosine theta over 2, in both cases, the only thing we need to know is cosine theta. So if they tell us cosine theta, all we really need to do is plug into the formula and decide if it should be positive or negative. Now we're going to have problems today where they give us sine theta. That's going to be a little bit more work because then we have to figure out what cosine theta is. But by the formula, cosine of theta over 2 is plus or minus the square root of 1 plus cosine theta all over 2. So then we can simplify. This is going to be plus or minus the square root of 1/25 over 2, which is plus or minus the square root of 1/50. In this problem, we still need to determine if it's positive or negative. And let's write this, let's simplify the radical but not rationalize the denominator. So first off, is it supposed to be positive or negative? You look at this. Theta is between 90 and 180, but you have to be careful. We're not worried about theta, are we? We're worried about theta over 2. So this is, you divide each part by 2. 45 degrees is between, or theta over 2 is between 45 degrees and 90 degrees. So it is between here and here. So the cosine should be positive, and the square root of 1/50th can be written as 1 over the square root of 50, which is 1 over 5 root 2. So we simplify the radical, but no need to rationalize the denominator. In this problem, we have a little bit more work to do because they give us sine. For half-angle formulas, sine is never used in the formula. But knowing sine and knowing this allows us to figure out what cosine theta is. We are between pi over 2 and pi. So our triangle will be in this quadrant. We know that sine of theta is 7 over 25. So we have to use Pythagorean theorem to figure out this, which is what?
You didn't let me finish.
24. That tells us that cosine theta is negative 24/25. So you just have to be aware that since we're in the second quadrant, cosine should be negative. At this point, we know that cosine theta over 2 is positive 1 over 5 root 2, obviously. Because at this point, we know cosine theta is negative 24/25. We know theta is between pi over 2 and pi. It's the same exact question we had before. Just given where the quadrant is given to you in radians rather than degrees. This one. We're told cosine theta is negative 1/2. Theta is in the third quadrant. Find sine theta over 2. Sine theta over 2. We can plug directly into the formula because they told us cosine. This is plus or minus the square root of 1 minus cosine theta all over 2. What is 1 minus negative 1/2? So this is plus or minus the square root of 3/2 over 2. What is 3/2 over 2? 3/4 plus or minus the square root of 3/4. So let's simplify our radical, and we still have to determine if this should be positive or negative. To determine positive or negative, we look at this guy right here. Theta is between 180 and 270. That means that theta over 2 will be between 90 and 135, which is here and here. So cosine should be, and root 3/4, so this is positive because of this. And then the square root of 3/4 simplifies to be square root of 3 over 2. Which we could have gotten in a different way, noticing this. This information right here tells us that theta is 240 degrees. If we know the cosine's negative 1/2, and we know that theta is in the third quadrant, 240 degrees has to be the answer. And we should all know that then sine of theta over 2, sine of 120 degrees, is root 3 over 2. Same thing. Just a different way of doing it. So here, you're told sine. So the first thing that we have to do is determine what cosine is. We know that we are between pi and 3 pi over 2. So my triangle should be here. Sine is 7 over 13. So what is that length? When you do Pythagorean theorem, this length is root 120. But we all know that root 120 is 2 root 30. Telling us that cosine theta is going to be 2 root 30 over 13. And it should be negative because we are in the third quadrant. Cosine's negative. So we know this now. Now we get to use our half angle formula. cosine of theta over 2 is plus or minus the square root of 1 plus cosine all over 2. Like that. So in the numerator, we have to subtract fractions. So we get the square root of 13 minus 2 root 30 all over 13 all over 2. So then that can be plus or minus the square root of 13 minus 2 root 30 all over 26. Should it be positive or negative? If theta is between pi and 3 pi over 2, then theta over 2 is between pi over 2 and 3 pi over 4, here and here, so cosine should be negative square root 13 minus 2 root 30 all over 26. That isn't going to simplify, so we just leave it like that.